In this video, we want to find the remainder if this fifth degree polynomial is divided by the binomial x minus 2. And we're going to look at three ways in this video. You can try it and just give whatever way you know, and then I'll come back. So the first way we'll do it will just be regular long division. We want to know the remainder if this polynomial is divided by x minus 2. So we can just use a long division here. We want the divisor in descending powers, the same sort of thing with the dividend here. So the highest degree term goes first. If there's any missing terms, you can put a 0 there, or just leave a space. So we have x to the fifth minus 24, and this is x to the fourth, plus 3x cubed minus 4x squared plus x plus 17. We're dividing by x minus 2. So highest degree term here divided by the highest degree term of the divisor. So it'll be x to the fifth divided by x is x to the fourth. We go x to the fourth times x is x to the fifth. Then x to the fourth times the minus 2. Very similar to what you do with long division of regular numbers. And this is just a minus 2 here. X to the fourth. And then we just subtract here. So subtract, this is cancels x to the fifth minus x to the fifth cancels minus 2, x to the fourth and a minus, and subtracting a minus 2, x to the fourth, these cancel out. So the other ones we just bring down. Got 3, x to the fifth, or x to the third I should say, minus 4x squared plus x plus 17. And we proceed again. So 3x to the third, that becomes your new dividend. We're still dividing by x minus 2, so x to the third divided by x gives me a plus here. That's the 3x squared. And then we multiply. So it's 3x squared times x gives me a 3. X to the third, and then 3x squared times a minus 2 is a minus 6. That's x squared, and then we subtract. So 3x cubed, subtract 3x cubed, those cancel out, go to 0. Minus 4, subtract the negative, minus 4x squared, subtract the negative 6x squared. This becomes a plus, so it's a plus 6. X squared and a minus 4 x squared gives me a 2 x squared, and then we just bring these others down. We're subtracting 0 from those, so bring them down, plus x plus 17, and then we continue. You keep dividing until the degree of the remainder is less than the degree of the divisor. So we continue to divide here. So x into 2x squared gives me a plus 2x. And then we continue, multiply this partial quotient times the divisor. So 2x times x is 2x squared. 2x times the minus 2 is a minus 4x. And then we subtract. 2x squared, subtract 2x squared, cancels to 0. And then x, subtract the minus 4x, that becomes a plus 4. So 4x and 1x is 5x. This is 5x here. And 0 from 17 is 17. And then I'm going to bring it over here to the side over here. Run out of space there, so 5x. And that's a plus 17. This is still your remainder here. And notice it has degree 1. The divisor has degree 1. So this has to be less than 1. So we can divide again. So x into 5x is a plus 5. And then we multiply 5 times x is 5x. And 5 times a minus 2 is a minus 10. And we subtract here. 5x subtract 5x, cancel. 17 subtract a negative 10, that becomes a plus 10. So 17 and 10 gives me 27. So the answer to this one is the remainder, I'll use R for remainder, is equal to 27. So notice the complete quotient is x to the fourth plus 3x squared plus 2x plus 5, but it just wants the remainder. So we do all of this just to get the remainder. So the remainder is 27. So that's one way to do it. We'll do it 3 ways here. The next way is just to use, again it's division, but this is a synthetic division. It's a shortcut of what I just did. So what you do here is you take the coefficients of the polynomial. So coefficients, okay, x to the fifth has coefficient of 1, x to the fourth coefficient of negative 2, x cubed has a coefficient of 3, x squared has a coefficient of a negative 4, x has a coefficient of 1, and the constant here is 17. Now if there's any missing terms, so let's suppose we didn't have a term, suppose I went from x to the fifth to 3x cubed, we wouldn't have an x to the fourth term. So you put a 0 right there. Or say we didn't have this constant, the 17, you put a 0 there. So make sure you do that. It's possible you could get the answer right by an accident, but in general it's not going to work. Okay, so then you do this then. This works basically when you're dividing linear factors of the form x minus k. So it's x, in this case it's x minus 2, so whatever k is, you put it right here. This is a 2. Now had this been x plus 2, and then you do the opposite and put a negative 2 right there. X minus 2 would be 2. X minus 3 would be 3 there in that little box. X plus 3 would be a negative 3. And then it's just an abbreviated form of what it just did, long division. Bring down the 1 below this line here. And then it's 2 times 1 is 2. Then you add these. Negative 2 and 2 is 0. And then 2 times 0 is 0. Bring it to the next column. 3 and 0 is 3. 2 times 3 is 6. Bring it over to the next column. Minus 4 and 6 is 2. And then 2 times 2 is 4. Bring it over to the next column. 1 and 4 is 5. And then again, 2 times 5 is 10. Bring it over to the last column. 17 and 10 is 27. That's your remainder. So again, the remainder is 27. Synthetic division can also be used when you're solving equations, when you're trying to find the zero of a polynomial, and other things that you'll do with it in more advanced mathematics. But for right now, this basic concept of the remainder is 27. Another way to do it is to do this. The remainder theorem simply tells you if you have a polynomial, say p of x, and say this polynomial is divided by a factor of the form x minus k, which is, in this case, it's this polynomial divided by x minus 2. So the theorem tells you if the polynomial p of x is divided by x minus k, then p of k says if you evaluate the polynomial at whatever k is, that's going to give you the remainder. So what this means then is if you take this polynomial right here and evaluate it at 2, and it was put at 2 wherever an x is, 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 squared, 2 there, and do the multiply out the coefficients to. If you do all of that, you're going to get 27. Okay, that's another way to do it manually. And actually there's a fourth way, which is basically the same sort of thing. Let's do it here on the calculator. And that's this way. If I take the calculator and enter the polynomial. So I've already entered it, so I have it there. X to the 5th minus 2x to the 4th, and so on all the way down. And then the last term there is 17. Just go to second, calculate, and you want value. Hit 1 here, and just enter the value you want. So you want to know what is the value of this polynomial, or what is it? If you evaluate this polynomial at some number, what is that number? Well, in this case, we want to evaluate it at 2, because that's what the remainder theorem states. Okay, if you evaluate the polynomial at, divide the polynomial by x minus k, then p of k is the remainder. So what do we want here? K is 2, so enter at 2, hit enter, and you get 27. So if you have a polynomial and you're dividing it by a binomial of the form x minus k, in this case x minus 2, and you just want to know the remainder, well, you can still do it long division, you can use synthetic division, or you can use the remainder theorem in your calculator. Thanks for watching. We'll see you next time.